So the continuation for Fresnel-Huygens principle. So the basic integral, the integral form of this was that it's the to validate it, we try to find integral of a thing. That thing is that it's the integral of amplitude. Okay, let's just say this r naught plus s, r naught plus b, actually r naught plus b, wait, no, ik r naught plus s by, man, wait, acha, see, basically, yeah, the figure helps. Basically, this is r naught and this is b. This is a secondary source. Fresnel-Huygens says that this point acts as a secondary source. That's what it says. The basic statement is this. Now we try to validate it with the integral. What's that integral? Let's see. This is s, this is s, this is q. So we were trying to see that the integral of a e or minus ik r naught by r naught, this is the amplitude at q, times ikb by b, the area ds. I hope this was it. Yeah. IKS, acha. Okay. The distance here is s, so yeah, the distance from point q to this p naught is s, so ds. Okay, and the integral limits are over the surface. Yes, we take all the surfaces. So s is equal to u at p. We shall try to evaluate this. This should kinda lead to a times e power minus ik r naught plus b by r naught plus b. This is the ultimate thing. This is due to primary source. As a primary source, seeing things from primary source. Okay. So let me check if the mic is on, right? Cool. So yeah, what we have realized is that there is an inclination factor k of chi which is equals to 0 for chi is 90. Okay, cool. That is one thing. This was the realization of only a pi angle arc. This is the secondary wave. Okay, secondary wave, it won't emit a complete spherical thing, only a hemispherical thing. Hemispherical thing. Yeah. Okay. I just lost the zeal, right? The zeal I had during the first part. It was interesting actually. The first part was interesting. What Wi-Fi did I connect? I want to connect to Days 5G. Man. Days 5G. Cool. Now I can connect to my server actually. I have to connect to the server. Yeah. So k of chi, the inclination factor, vanishes at chi is 90. So we only have influence from these secondary sources. Okay, these secondary sources only, because this is a tangent. Okay, this is a tangent. Fine. The sources till here play a role in that. So what we have done to evaluate this was u of p is equals to integral over s. Okay, wait. E minus ikr naught by r naught. This is a constant s times e power minus iks by s. We have evaluated ds using cosine rule, and also saying that ds is equals to what is said, r square sine theta d phi. Yep. So, and we have substituted the sine theta thing from here. Yep. So this is the theta here. Yeah, that is theta. We applied a cosine rule. We applied the cosine rule and got the fact that, and we got something like r naught by r naught plus b times ds times d phi. If I'm not wrong, this is the thing. R naught s ds. Acha. Okay. Okay, fine. So we have surface integral, that is two variables, of course. So minus ik r naught by r naught times still minus iks ds 2 pi. Yeah, and we have also realized this thing, that this is the z-axis. If this is theta, the inclination is theta, then this sweep is given by phi, and this inclination, yeah, the r takes care of this, the theta takes care of these things. I mean, yeah, here, perhaps there's these points, right? These points, the phi, it revolves up. What do you say? It not revolve it. Yeah, whatever. Circulates it. So this is the thing. So we have no r naught now. The r naught thing vanishes, and we have r naught plus beta ds. SA had this. It was not that. See, I forgot the essence of it, right? I forgot the essence of it. Exactly. I forgot the main thing of secondary waves, which is chi factor, man, the inclination factor, right? Every source has an inclination factor. Now these and s, it is dependent, because so you see the inclination factor varies for this surface, this surface. Okay, right? So what we are going to do is construct zones with center this, we construct zones. Now only few zones are influencing this, of course, as discussed. Chi becomes 90, that's why. And yeah, so we constructed zones, right? Each zone is something like b plus j lambda by 2, starting from b. Cool. Plus j lambda by 2 zones, and we are saying that this lambda by 2 factor is small enough, okay, small enough for to construct some closely infinitesimal things, each zone affecting here with equal k chi. So we take out k chi j and then see for zone. Exactly. J at the zone calculation is done like this. U of p equals amplitude 1 by r naught 2 pi for a zone, exactly, right? For a j at the zone, we have jth k chi, and we have limits. Now the important assumption is here that is that r naught and b are greater than lambda, and I have spoken about it, saying that it is sufficient enough to consider these things. This is S, this is B, S is approximately B, right? Because for longer radii compared to wavelength, this kind of holds. And I think that is where I wrote the microscopic things, or no? No. I wrote for exactly. Right? Exactly. So now we are evaluating it for each zone. Cool. Cool, right? Cool. Yeah. So it is like for one zone, for some jth zone, for arbitrary jth zone, b minus j, wait, no, b plus j minus 1 lambda by 2 to b plus j lambda by 2 of minus IKS ds. Now this should technically yield I have solved this. What was that? Yeah, IK. Yep. Nice. Okay, so this is fine. This is also fine. We have got here minus 1 power j, minus 1 power j, minus 1 power j, 4 pi I by k. Okay, there's a 2 factor out, huh? There's a 2 factor out. Cool. Yep. Okay, e power I pi equals minus 1. So cool. So looks like we get u of p equals for jth zone k r naught by r naught 4 pi I by k times kj chi minus 1 power j. Yep. Yeah, this is the equation we now carry on. So just the central idea, we shouldn't forget the central idea. What was the central idea? We are proving that a light source is emitting some points, and then each point behaves as a spherical wave with some inclination factors, and those factors we see that the field at here is same as this. We're trying to validate that. Do you see that? Okay, cool. Yeah, it sounds trivial sometimes, like we're trying to just integrate stuff. What's interesting in that? Well, this is very interesting. It is interesting. For some reason at least. I don't know why. It is interesting. Yeah, so so we have arrived at a point where we were writing it as this capital is making a mistake. 2 u of p is equals u of u at p to the jth zone is k j chi times 4 pi I by k times, this is important, but R naught, it's not there actually, R naught plus B, R naught plus B, R naught plus B times what this is the transformation through Huygens construction. That's what we got. So we should move on. Now we should try to sum it up. Sum the over j, and yeah, try summing up. For that we need to evaluate kj, the sum of kj. See, it's like alternatively varying in direction of field. One zone is adding, one zone is subtracting. So yeah, let's see.